All right, so welcome back to the Civil FE review. Today in this video, we're going to be looking at water resources and environmental engineering. And this is the first section of this topic. And we're going to be first starting out with basic hydrology. So let's buckle up and let's go ahead and get started with these problems. All right, so number one says a 53-acre watershed with a curve number equal to 79 receives 122 millimeters of precipitation. All right. Calculate the maximum basin retention in inches. Okay. So what is the information that I'm given? Let's get a green for passing. So given information is, we have our curve number of 79, right? We are also given that the amount of precipitation and we're also given the area. Okay. And so calculate the max. So we're trying to find the max basin retention. And it should be in inches, right? Okay. All right, so I'm just gonna look up. I don't know what formulas I need to use for this. It's a bunch of random data for me that I'm just gonna look up what I'm trying to find, which is basin retention. One thing comes up. And okay, S is equal to maximum basin retention in inches. Cool. So I feel like I may be in the right area. It's the only thing that I searched as well. So S is equal to, okay, 1000 over Cn minus 10. Cn is a curve number, and we have a curve number, which is 79. So I have all the variables I need to be able to solve this question. So I'm going to say S is equal to 1000 over the curve number minus 10. My curve number is equal to 79. So this is all going to be equal to 1000 over 79 minus 10. And so S, or the maximum basin retention in inches, is going to be 2.65 inches. So I get D. Let's look at number 2. Number 2 says a 871,200 square foot parcel of land has a rainfall intensity of 1.5 inches per hour and a rational method runoff coefficient C of 0.1. Okay, the flow rate in cubic feet per second for this site is most nearly what? Okay. So what information am I given? Well, I'm given the area, which is 871,200 feet. I'm also given a rainfall intensity, and as you're writing this stuff out, normally if it has a number beside it, I write it down, or if it's like a method or some type of system, I write down. So we have a coefficient, and it's the rational method coefficient, and that's pretty much it. And then we're trying to find the flow rate. for this site. Okay. So what formulas might I need? Well, I think we're already in the right section, right? But I would start with the rational method, rational formula, which is going to be here. Q is the peak discharge or the flow. C is the coefficient, the runoff coefficient, which looks like we do have this rational method. And then A is we have it, but we don't have it in acres, so just something to note. And I, we have the rainfall intensity in inches per hour. So we have all the information we need to get Q, or the flow rate. Okay. So Q equals CIA. C. Let's write down the C. C is the runoff coefficient. And so C is equal to 0.10. All right, what about I? I is the rainfall intensity here, and it needs to be in inches per hour, and we have it in inches per hour. That's 1.5 inches per hour. All right, A is equal to 871,200 SF, and we need to get this in acres, right? A needs to be in acres here. Okay, so how do I get it in acres? Well, I have to do some fun stuff. So I would go to my unit conversion section of the handbook and see if I can get any information. So in the handbook, gives us a bunch of different stuff. So can we go from square foot to acres, or acres to square feet? Okay. We can. So from looking at this handbook, I know that for 1 acre, it's going to be 43,560 square feet. So we can do a unit conversion, right? So 1 acre is equal to 43,000. So you don't have to memorize this stuff. The handbook gives it to us. SF. Okay, so my units will cancel. And for that, for my A, get 20 acres. All right. So now what is my Q? Q equals C times I times A. So I know that it's going to give me my units in cubic feet per second if I copy all of the right units for the other variables. So if I have everything in acres and inches per hour and my coefficient, my Q will come out in cubic feet per second. And that's what we need our flow rate to be in. So see what we get. I'm just going to plug and chug. This is equal to C 0.10 times I 1.5 times 20. Right? And for that, it ends up coming out to be 3 cubic feet per second. CFS is cubic feet per second. So we're gonna say, hey, all right, let's look at number 3. All right, using the rational formula, if rainfall intensity increases and the area and runoff coefficient remain the same, what happens to the peak discharge? All right, so we're going back. So we're using the rational formula again. So the given information is rational formula and rainfall intensity increases. Area my area, oh, can't write with yellow. My area stays the same, so flat, and the runoff coefficient stays the same. So we got to see what happens to the peak. So find what happens to the peak discharge. All right, so the formula is needed. I think I'm gonna need the rational formula. And that means that Q is equal to CIA, all right? So C is, again, the runoff coefficient. So if that's runoff coefficient is gonna stay the same. And we can do an example. So we will say that for the first iteration that the rainfall, the C, or the runoff coefficient, is going to be 1. The rainfall intensity is going to be 1, and then our area is 1. So Q in this case is equal to 1. Right? So what happens if we do what this question says, right? And we increase the rainfall intensity, or we increase I. Well, now, and we keep everything else the same. So our runoff coefficient is still 1. Our rainfall intensity increases. So I'm going to say it goes to 2. Jesus Christ. Goes to 2 times 2. And then my area is still 1. Well, now my Q, cannot see anything. So if you missed what I said, if I go back, I'm saying that my C, or my runoff coefficient, remains the same at 1. My rainfall intensity now increases to 2, and I've marked that in green here. And then my area stays the same. This is what the question says. So now my new answer is going to be 2. So what happened when I increased, what happens when I do what it says in the problem? My Q increases. It goes from the first value, 1, to the next value being 2. So it is if we were to increase our rainfall intensity and leave everything else the same, the peak discharge is going to increase as well. All right, so that concludes the first section of water resources and environmental engineering, specifically the basics, the basic hydrology. In the next section, we're going to be looking at basic hydraulics and specifically Manning's equation, Bernoulli theorem, and open channel flow. All right, see you in the next video.